You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Feedback loops are at the heart of agility, transforming delivery from a linear push of work into a responsive, adaptive system. They provide structured, repeatable ways for teams to detect value, risk, and quality signals early enough to act. Without feedback loops, uncertainty compounds, and issues only surface after investments have become too costly to reverse. With loops in place, observations from users, stakeholders, and delivery systems continuously inform decisions, enabling course corrections while change is still affordable. For example, discovering in a sprint review that a workflow confuses users allows adjustment before wide release. On the exam, feedback loop scenarios often test whether candidates recognize the importance of regular, structured channels over sporadic updates. The agile response usually emphasizes embedding feedback loops into the normal rhythm of work, ensuring that learning and adjustment are systemic, not accidental. Cadence selection determines how often feedback is gathered and reviewed. Different decisions require different rhythms. Operational checks must occur quickly to prevent disruption, while strategic reviews may require slower cadences to allow patterns to emerge. For example, system health may be monitored continuously through telemetry, while portfolio reviews occur quarterly. Misaligned cadences either produce stale information that arrives too late or noisy updates that overwhelm decision-making. Selecting cadence is about finding the sweet spot between responsiveness and stability. On the exam, cadence scenarios often test whether candidates understand how loop frequency should match decision needs. The agile response usually emphasizes proportionality. Feedback is most useful when its timing aligns with the pace of the decisions it is meant to inform. Stakeholder review sessions create structured opportunities to share observable product behavior and invite context-rich conversations. Unlike status meetings, these sessions focus on increments that demonstrate actual progress and outcomes. Stakeholders can highlight alignment gaps, clarify expectations, or redirect priorities before large investments accumulate. For example, in a sprint review, seeing a working prototype allows sponsors to compare it directly against their vision, prompting constructive feedback. Without such sessions, teams risk building in isolation, only to face rejection late in the process. On the exam, stakeholder review scenarios often test whether candidates can differentiate between reporting progress and inviting dialogue. The agile response usually emphasizes that transparency paired with conversation accelerates alignment. These reviews are less about proving completion and more about validating shared direction. Customer touchpoints provide direct input from the people who will actually use the product. Interviews, support pattern analysis, and usage reviews all ensure that decisions are anchored in real needs rather than internal assumptions or proxy opinions. For example, analyzing support tickets may reveal that a recently released feature is confusing, even if usage data looks strong. Without customer touchpoints, teams risk building products that satisfy internal expectations but fail in the market. On the exam, customer feedback scenarios often test whether candidates recognize the value of real users over surrogates. The agile response usually emphasizes grounding decisions in authentic user signals. Feedback from customers shortens the distance between design and experience, preventing costly divergence. Demonstrations of working increments represent one of the strongest feedback loops available. Documents and mock-ups cannot expose usability challenges or integration failures the way running software can. By putting increments in front of stakeholders, teams validate acceptance criteria and uncover issues in real usage contexts. For example, a stakeholder may notice during a demo that navigation is less intuitive than expected, feedback that would never surface in a status report. Regular demos also build trust by making progress tangible. On the exam, demo scenarios often test whether candidates recognize that working software is the ultimate measure of progress. The agile response usually emphasizes showcasing increments as the best way to invite actionable feedback. Demos ensure that what is being built aligns with expectations before too much effort is invested. Hypothesis tests for discovery strengthen feedback loops by framing assumptions explicitly. Instead of assuming demand for a feature, teams craft hypotheses with clear success criteria and test them through small experiments. For instance, a team might hypothesize that adding a search function will increase engagement and test it with a limited rollout. Results confirm or disconfirm the assumption, guiding whether to scale. This prevents investment in features without proven value. On the exam, hypothesis test scenarios often test whether candidates can connect experiments to reduced risk. The agile response usually emphasizes evidence-driven discovery. Hypotheses turn assumptions into testable statements, ensuring that learning is systematic rather than incidental. Operational telemetry creates continuous, low-latency feedback on how systems behave in production. Events, traces, and logs provide signals about performance, reliability, and user interactions in real time. For example, a spike in error rates after a release reveals issues faster than waiting for user complaints. Telemetry transforms production into a learning environment, enabling rapid detection and response. Without it, teams rely on lagging signals like customer dissatisfaction. On the exam, telemetry scenarios often test whether candidates understand its role in reducing risk. The agile response usually emphasizes automation and visibility. Operational feedback keeps systems trustworthy by ensuring teams are alerted to issues before they escalate into failures. Quality feedback loops ensure that teams maintain reliability as they move quickly. Automated tests, static analysis, and defect trend monitoring reveal regressions and hotspots that demand attention. For example, test automation may catch a critical security vulnerability before it reaches production. These signals not only prevent defects from escaping, but also highlight areas of code that require refactoring. Without quality loops, fast delivery erodes trust in the product. On the exam, quality scenarios often test whether candidates can connect technical practices to sustainability. The agile response usually emphasizes embedding quality feedback into everyday work. Continuous testing and analysis provide guardrails that allow agility to scale without compromising stability or safety. Flow metrics serve as feedback on the health of the delivery system itself. Cycle time, throughput, and work in process provide visibility into predictability and bottlenecks. For instance, rising cycle time variance may reveal hidden queues or overloaded policies. These metrics help teams improve not only what they deliver, but how they deliver. Without them, teams operate with blind spots about capacity and constraints. On the exam, flow scenarios often test whether candidates can interpret metrics as signals of system health. The agile response usually emphasizes that agility is as much about improving flow as it is about improving features. Flow feedback ensures teams can deliver consistently and sustainably, adapting their processes based on evidence rather than perception. Risk-oriented loops monitor leading indicators and assumption validity, providing early warnings that allow proportionate mitigations. For example, monitoring adoption rates in a pilot signals whether a new feature is viable before scaling. Tracking assumption validity, such as the availability of a critical vendor API, prevents surprises. Without risk loops, teams slip into reactive firefighting, addressing issues only after they harm users. On the exam, risk scenarios often test whether candidates can connect leading indicators to proactive action. The agile response usually emphasizes continuous risk monitoring as part of everyday work. Risk feedback transforms uncertainty into manageable signals, allowing teams to act responsibly before risks crystallize into crises. Voice of the employee channels provide feedback from the team itself. These channels capture impediments, tool friction, and coordination pain that slow delivery and erode morale. For example, repeated complaints about unstable test environments may highlight a systemic issue requiring leadership action. Without employee voice, teams may quietly suffer inefficiencies, leading to burnout or attrition. On the exam, employee feedback scenarios often test whether candidates recognize the importance of surfacing internal signals. The agile response usually emphasizes psychological safety and structured channels. Feedback loops should not only serve users and stakeholders but also the team, ensuring that conditions for sustainable performance are visible and addressed. Vendor and partner feedback integrates external dependencies into the learning cycle. Joint reviews, shared dashboards, and aligned evidence practices ensure that issues are identified early rather than surfacing at integration. For example, a vendor providing an API should participate in demos and reviews, receiving and giving feedback alongside internal teams. Without this, boundary issues remain invisible until late. On the exam, vendor scenarios often test whether candidates can extend loops beyond organizational walls. The agile response usually emphasizes that external partners must be part of feedback rhythms. Transparency across boundaries prevents surprises and builds stronger ecosystems. Compliance and safety feedback ensures that regulated environments meet obligations without slowing delivery. By integrating traceability checks, approvals, and safety evidence into routine work, teams avoid end-phase scrambles. For example, an automated log of test coverage can satisfy auditors incrementally. Without compliance feedback, surprises at audit time derail progress. On the exam, compliance scenarios often test whether candidates can embed evidence into loops. The agile response usually emphasizes integrating compliance into normal practices. Transparency about safety and accountability ensures agility is both responsible and sustainable. Feedback readiness closes the loop by ensuring signals actually lead to timely action. Defining clear owners, thresholds, and response windows ensures that feedback is not just observed, but acted upon. For example, an error spike may trigger a defined response within hours, owned by a specific role. Without readiness, feedback risks being ignored or delayed until damage occurs. On the exam, readiness scenarios often test whether candidates understand the difference between feedback signals and feedback systems. The agile response usually emphasizes that loops require response mechanisms, not just collection. Feedback is valuable only when it reliably triggers proportionate, timely action. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Signal quality practices ensure that feedback loops provide clarity rather than noise. Without consistent definitions, automated collection, and thoughtful summaries, signals may mislead more than they inform. For example, a team might track defects found without distinguishing between severity or source, leading to distorted conclusions. Automated pipelines that capture metrics consistently reduce human error and increase trust in the signals. Outlier-aware summaries highlight extreme cases that affect users, not just averages that hide variability. On the exam, signal quality scenarios often test whether candidates can distinguish between valid signals and vanity noise. The agile response usually emphasizes investing in clarity and reliability of feedback, ensuring that data reflects real experience. Transparency loses its power if signals are inaccurate, inconsistent, or ambiguous. Feedback routing makes feedback actionable by ensuring signals reach the right decision level. A defect trend belongs with the delivery team, while a systemic staffing gap may require leadership. Mapping signals to the forums that can act prevents delays and miscommunication. For example, a vendor's missed milestone might need escalation to program leadership rather than sitting in a team backlog. Without routing, feedback risks becoming trapped at the wrong level, where teams lack authority to act. On the exam, routing scenarios often test whether candidates recognize that feedback must flow to the forum with decision rights. The agile response usually emphasizes clarity and pathways. Feedback without a recipient is noise, not a loop. Effective routing connects evidence to the authority capable of acting on it. Visualization and narrative context make feedback interpretable. Dashboards provide concise visuals of trends, while narratives explain why those trends occur. For example, a rising defect rate might coincide with deliberate stress testing, a detail that numbers alone cannot convey. Without narrative context, stakeholders misinterpret data, triggering poor decisions. Visualization keeps information concise, while plain language ensures shared understanding across technical and non-technical audiences. On the exam, visualization scenarios often test whether candidates can balance quantitative and qualitative signals. The agile response usually emphasizes pairing data with story. Feedback is most effective when it is both visible and contextualized, allowing stakeholders to see not only what is happening but also why. Backlog integration ensures feedback translates into changed priorities, refined items, or updated acceptance criteria. For example, customer complaints about onboarding may be logged as backlog refinements that reprioritize usability improvements over new features. Without integration, feedback remains detached from delivery, acknowledged but not acted upon. On the exam, backlog scenarios often test whether candidates understand how evidence must feed directly into work. The agile response usually emphasizes that feedback loops end only when signals reshape backlog priorities. Agility is not only about hearing feedback but about weaving it into the planning and execution rhythm, ensuring that delivery reflects learning in real time. Guardrails for experimentation protect feedback-driven learning from creating harm. Testing hypotheses with users must respect ethical, privacy, and safety obligations. For example, an A/B test on pricing should include safeguards to avoid unfair treatment or regulatory breaches. Guardrails provide confidence that learning never compromises responsibility. Without them, teams risk damaging trust or creating legal exposure. On the exam, guardrail scenarios often test whether candidates can balance experimentation with responsibility. The agile response usually emphasizes boundaries that preserve fairness, safety, and ethics. Experimentation is a cornerstone of agile learning, but it must always occur within clear, principled limits to maintain organizational integrity and user trust. A/B and multivariate tests strengthen feedback loops by isolating the effects of changes. A/B tests compare two versions, while multivariate tests explore combinations of factors. These experiments increase confidence in conclusions by reducing confounding variables. For example, an A/B test might confirm whether a new call to action increases click-through rates. Without structured testing, teams rely on anecdote or assumption. On the exam, testing scenarios often test whether candidates can connect controlled comparisons to confidence in evidence. The agile response usually emphasizes small, controlled tests before scaling. Structured experimentation turns feedback into statistically credible learning, reducing the risk of acting on false signals or noisy data. Service-level objectives and error budgets integrate reliability into feedback systems. SLOs define acceptable performance targets, while error budgets specify how much failure can occur before corrective action is needed. For instance, if uptime drops below 99.9%, new feature work may pause until stability improves. This balances innovation with user commitments. Without SLOs and budgets, teams risk prioritizing speed over trust. On the exam, reliability scenarios often test whether candidates can link feedback to operational accountability. The agile response usually emphasizes that feedback loops include service reliability. By connecting user commitments to delivery decisions, teams ensure that innovation never undermines basic trust in the system. Remote-friendly feedback ensures that distributed teams have equal access to signals. Practices include searchable artifacts, asynchronous updates, and recorded review sessions. For example, posting demo recordings allows teams in different time zones to provide feedback asynchronously. Without remote-friendly practices, distributed groups risk exclusion, reinforcing silos. On the exam, remote scenarios often test whether candidates can adapt feedback loops for inclusivity. The agile response usually emphasizes intentional design of tools and cadences. Feedback must flow across geography and schedule to sustain agility globally. Remote adaptation prevents transparency and learning from being privileges of co-located groups. Anti-patterns in feedback loops reduce their effectiveness and waste energy. Vanity metrics provide numbers that look positive but do not influence outcomes, such as tracking lines of code written. Dashboards without owners decay into irrelevance, while one-way presentations provide information but never result in changed behavior. For example, weekly updates that are read but never acted on signal wasted loops. On the exam, anti-pattern scenarios often test whether candidates can identify dysfunctional feedback. The agile response usually emphasizes detecting and eliminating loops that do not drive action. Feedback must lead to adaptation. Otherwise, it is noise masquerading as progress. Continuous improvement of feedback loops ensures they evolve alongside teams. Reviewing usefulness, latency, and cost of collection helps prune low-value signals while amplifying those that matter. For example, a team may drop redundant metrics while enhancing telemetry on user behavior. Without review, feedback systems accumulate noise and overhead. On the exam, loop improvement scenarios often test whether candidates recognize the need to adapt the system itself. The agile response usually emphasizes iterative improvement of how feedback is gathered and used. Loops are not static. They must be refined to remain relevant, efficient, and impactful. Escalation triggers define when adverse signals demand broader attention. For instance, if defect rates exceed a defined threshold, an escalation may trigger leadership review or a pause on feature work. Without clear triggers, adverse signals may be ignored until too late. Escalation ensures proportional responses and protects users from unmanaged risk. On the exam, trigger scenarios often test whether candidates can recognize the importance of escalation thresholds. The agile response usually emphasizes explicit definitions of when feedback warrants wider action. Escalation protocols turn transparency into accountability, ensuring signals never languish unheeded. Learning repositories preserve insights beyond the lifespan of individuals or teams. By storing test designs, outcomes, and decision rationales in structured repositories, organizations prevent knowledge from being lost. For example, documenting the rationale for a failed feature experiment prevents repetition of the same mistake. Without repositories, feedback remains local and ephemeral. On the exam, repository scenarios often test whether candidates can connect organizational learning to feedback loops. The agile response usually emphasizes preserving and sharing lessons. Learning compounds only when it is accessible. Repositories transform fleeting observations into enduring assets for the organization. Portfolio-level synthesis aggregates feedback across teams and products, detecting systemic issues and informing strategy. For example, repeated complaints about integration complexity across several products may signal an architectural problem requiring investment. Aggregated feedback provides leaders with patterns that single teams cannot see. Without synthesis, organizations miss opportunities to address root causes. On the exam, synthesis scenarios often test whether candidates can connect feedback to strategy. The agile response usually emphasizes looking across silos. Feedback loops create maximum value when aggregated and interpreted at scale, guiding resource allocation and long-term planning. Success criteria for feedback loops evaluate whether the system pays for its complexity. Loops are successful if they shorten time to learning, improve outcomes, and reduce rework. For example, if experiments yield faster insights into customer needs, loops are achieving their purpose. Without criteria, feedback risks becoming ritual without effect. On the exam, criteria scenarios often test whether candidates can measure the value of loops. The agile response usually emphasizes evaluating loops by outcomes, not activity. Feedback systems must deliver tangible benefits, or they should be pruned. Success is proven when loops demonstrably accelerate learning and decision quality. In conclusion, feedback loops transform agile delivery into a system of constant learning and adaptation. Their effectiveness depends on purposeful cadence, reliable signals, and disciplined routing into decisions. Hypothesis tests, experiments, and telemetry provide learning. Backlog integration and escalation ensure action. Guardrails, repositories, and portfolio synthesis protect ethics, sustain learning, and scale insights beyond individuals. Anti-pattern vigilance and continuous improvement keep loops lean and relevant. On the exam, candidates will be tested on their ability to distinguish functional feedback loops from ceremonial ones. In practice, organizations that master feedback loops adapt faster, reduce waste, and deliver outcomes that remain aligned with both user needs and system realities. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.